Hi, this is Mr. Weston. Today we're doing a walkthrough video for Quadrilateral Area Sheet 1. This is from Math-Salamanders.com. Make sure to check them out. They have tons of great, awesome resources and worksheets. Make sure to check it out in the link. So, what is a quadrilateral? That is a four-sided shape, and there's a couple different types here. You'll see that we have some parallelograms, some trapeziums, also known as trapezoids, and also another one. And the hint is to split this up into rectangles and triangles. For the parallelograms, like in number 1, this is a parallelogram, and I know because it kind of looks like a rectangle that's just been slanted over. Kind of like if you were to step on a rectangle. So if I'm going to draw a rectangle real fast here, there's a rectangle, and if I step on it with some force going to the side, you might see it slant like this. If you ever had like a flimsy box, that will do that. But that's what a parallelogram is it just has these two sides that are parallel to each other right here, and then parallel sides right there. So two sets of parallel sides. What is the formula for finding the area then? Well, it's similar to the rectangle. The area of a parallelogram is the length times the perpendicular height. Let's talk about that real fast. Let me erase this. So if we're talking about the length, well, we're going to talk about the length as one of the sides, and then the perpendicular height. This is very important that it's mentioning the perpendicular height. One mistake I see a lot is students will multiply it by this distance right here. So let's just say this is like 5 centimeters, and I'm talking about this distance right here. Don't multiply it by that. That's not perpendicular. It has to be in the middle, or at least 90 degrees here, like that. Okay, so it has to be by that perpendicular height. But once we multiply those two things, that's going to give us our area. So area equals our perpendicular height. That's 8 times our perpendicular height? I meant our length, 8 times our height, which is 4, and that gives us 32 centimeters squared. And that's all there is to it for parallelograms. So let's take another example. Number 3 is another parallelogram. The reason why I know is it looks like that squashed rectangle. So here we have a length. Okay, let me try to use the same colors this time. So we have purple. That's our length. And then this is our perpendicular height, 6. It's not giving us that 90-degree angle, but we can assume it. Just know that it's not like this side right here. Okay, can't use that. That is a no-go for finding the area of a parallelogram if we're given the other length right there. Okay, so we have 7 and 6, so we're just going to multiply 7 times 6. So we have 7 times, and then we have 6. We're going to multiply that, and we get our answer of 42. So that's all there is to parallelograms. Those are pretty simple. There's one more, so let's go ahead and do it. Here we have our length. Here we have our perpendicular height. We just multiply 5 times 6, and that gives us 30. So parallelograms, done. Trapezoids. So trapezoids, it even gives us the formula here, but I want to show you why the formula for the trapezoid works, or trapezium. Let's take a look at the shape. You can probably build it. It says try to split it up into rectangles and triangles. Well, we can split this up into a rectangle by drawing these lines like this. So we have a rectangle. Rectangle is a shape with 4 90-degree angles. And then we have these two triangles. I'm going to draw those, and let's go green. So I have 2 triangles here, 2 skinny triangles, plus that rectangle. Well, what are the dimensions of that rectangle? Let's start with that. The dimensions of this rectangle are going to be 5 by 3. So I have 5 centimeters on the top. If I drew it straight down, it's also 5 centimeters on the bottom, and then I have 3 centimeters on the side. Well, the area for a rectangle is length times width. So I just do 5 times 3, and that equals 15 centimeters squared. Now, I have these 2 green triangles that I still have to figure out, so let me just take one and then I'll double it, okay? Because they're going to be the same. This is an isosceles trapezoid. So let's just talk about the dimensions real quick. This is going to be 1 centimeter, and this is going to be 1 centimeter. Why? Because this 5 that I had here, so I'm looking up here now, so this 5 distance is that 5 distance. We have these triangles added on to it, okay? So we have these little triangles here. And we know that 5 plus whatever that distance is and whatever that distance is, plus needs to equal 7 centimeters. So obviously it's going to be 1 and 1. So 1 centimeter, 1 centimeter, this is 1 centimeter here, this is 3 centimeters here. We need to know our area for a triangle, so I wrote that down here. Area equals 1/2 times the base times the height. So 1/2 times base times height. Well, our base is going to be 1, so let's do area of this triangle here. It's this green triangle equals 1/2 times our base, which is 1 times 3. Well, that equals 1.5 centimeters squared. And that's just 1. So we're going to double it for 2 because we have 2 identical triangles. So we're going to get 3 centimeters squared for the area of that all the green space. So we're going to add that 3 centimeters squared here, 3 centimeters squared, and we get 18 centimeters squared, and that is going to be the area of this whole trapezium. Okay, that was a lot of work. Let me show you the quick way. The quick way is to do length 1 plus length 2, and then multiply it by the height. Let me show you that real fast. So length 1 and length 2. I need to probably change the color. That will make it a little bit easier. This would be length 1, and this would be length 2. We don't need to be worried about splitting up into different shapes for this formula. Okay, so we have length 1. Let me change it to blue. Length 1 is 5 plus 7. We need that in parentheses. What do we do next? We multiply that by 1/2. And then we also multiply by this perpendicular height, by 3. So we multiply it by 3, and that's going to be our area. So we do 5 plus 7 first. That's 12 times 1/2 times 3. It doesn't really matter the order we do this in. I'm going to do 1/2 times 12 first right here, and that gives me 6. What is 1/2 of 12? That is 6 times 3. That equals the area, and we get 18 centimeters squared. We got the same thing using the formula. The formula takes into account that you're going to be adding that triangle in there to that rectangular shape. If we looked at this problem, number 5, we can split it up again. We would have a rectangle with 5 by 2, a 5 by 2 rectangle. So we do 5 times 2 to find that area. We'd get 10, and then we could add on this triangle. Remember how we had a triangle before? Well, it's a trapezoid, so you're always going to have that little extra triangle on there. That's one way to do it. Okay, so we could figure out that this is 4 centimeters because 4 plus 5, those two need to add up to this 9. And then we already know that that's 2 centimeters there. Okay, so that's one way to do it. You can figure out that area of that triangle. I'm going to show you the quick way, which is to add 5 plus 9. So the area equals 1/2 times 5 plus 9, and then multiply by our height times 2. So we have 14 times 1/2 times 2. I'm going to get 7 times 2 once I do 1/2 of 14, and I get 14 centimeters squared. You get the same thing if you were to use the triangle way, split it up with a rectangle. This last shape is actually a kite. So this one will not be a formula that we have listed here. We just need to split this up into 2 triangles. So we have a triangle here, that's in green, and then we have one beneath it. Now you're probably like, well, what's the height? Well, the height is going to be exactly the same for this other triangle. So really we just need to find this triangle and multiply it by 2. Well, how do we find the area of the triangle? Let's review that again. 1/2 the base times the height. And so that's going to be 1/2 the base, which is 10, times the height, which is 3. So we get 5 times 3. That equals 15 centimeters squared. And that's going to be the area of just one of these. So we have to times it by 2. Once we times it by 2, we get 30 centimeters squared. And that's going to be our final answer. Now, real quick bonus, if you're looking for the area of a kite, there is a formula. And I do a lot of geometry videos if you want to check those out. But area of a kite is actually 1/2 times diagonal 1 times diagonal 2. What is the diagonal? The diagonal are these lengths that I'm about to show you. Whoops, I didn't mean to erase that much. Hope you don't mind. You can rewind if you need to see it. So diagonal 1 would be that all the way across, and then diagonal 2 would be all the way across like that. So kind of like the supports of a kite if you go and fly it. So those 2 distances all the way across. So that's it for this video. I hope you enjoyed it. If you have any questions on it, make sure to leave a comment. And make sure to check out my other Math-Salamanders videos on the playlist. And I look forward to seeing you next time right here on Wes Explains Best.